Hi, I'm Krzysztof Kaczor, and some of you might know me because I used to live in Wrocław for a couple of years. These days, I work in Warsaw. I work for a company called Maker Foundation, where we develop a decentralized stablecoin called DAI. And and so it's like a cryptocurrency like Bitcoin, but it has a stable value like a dollar. And I'm telling you this because obviously we're always looking for good TypeScript engineers willing to relocate to Warsaw. So if it sounds interesting for you, just let me know. But today I'm not going to talk about cryptocurrencies. Today I'm going to talk about an assertion library that loves TypeScript. It's called Earl, and I created it with a couple of friends. And I know that it might look like I'm trying to give a presentation from within Visual Studio Code, but this is exactly what I'm trying to do. So stick with me. I hope it works. So let's start. By the way, this is the first and the last diagram that I created for this talk, so no more ugly diagrams by me. So first, let's talk about what are the test runners, testing frameworks, and assertion libraries. So test runners are pieces of software that execute your tests. So usually they come in a form of a CLI that takes some glob pattern of files containing your tests, and it executes them. Then we have testing frameworks, and every time you use it, describe, test functions that take another functions, you interact with the API surface of testing framework. So we use testing framework for defining tests really in code. And an example of testing framework, for example, is Mocha. Then we have finally assertion libraries. And assertion libraries are used to create, express some assertions. And as you might know, node.js comes with a standard, like very basic assertion module, but probably, as you can imagine, there's a pretty huge space of available designs out there, and Earl is one of the assertion libraries that you can find now. Another assertion library that is pretty popular is Chai. So let's dive a little bit more into libraries that I mentioned. So let's start with Mocha. So Mocha is test runner and test framework. So we have some code snippet here. You have this describe, it, blocks, and you have CLI to run the tests. And Mocha is one of the oldest node projects out there. I think like it's probably 10 years old at least. And despite being old, it has quite modern features, and it's actively maintained. So for example, it supports config files, it has watch mode, it has parallel test execution. And there's one particular feature that I love, is that you can isolate a single test case with using .only. So so you can just do it.only, and test runner will execute only this test. And this is quite handy when you need to do some heavy debugging with connecting your debugger using your IDE or whatever, and that's quite awesome. And the last thing that I enjoy about Mocha is that it's simplicity. Like it doesn't try to do things that it shouldn't. Like it does only few things, and it do it pretty well. Then we have Chai. So Chai is an assertion library, and it's pretty commonly used with Mocha. So every time you see expect foo followed by a lot of dots, which is a chaining mechanism, that means probably it's Chai. So so yeah, Chai features this chaining, and I gotta admit I'm not the biggest fan. So the simplest assertion would look like expect foo to be equal to something or to be deep equal. But you have all like many other matchers, and as well you have all these different properties that are often optional or are totally synonymous to each other. So it can be to be a string, or it can be to be n string, and you know you have all these different variations of the same thing that you know that are spelled differently. So that's not that great. It lacks type safety, so you can try to compare apples with oranges, and it will fail only during the runtime. And it was last published on npm was 2 years ago, so it's not that actively maintained, as you can imagine. Now, finally, we're getting to jest, and I'm pretty sure that many of you heard and used jest before. So it got particularly popular with React, I think, but now it's being used to test everything. And it's test runner, testing library, and an assertion library. So even though it's split into a few different smaller pieces, for the end user, it presents itself as a monolith. And I think it's pretty cool because, you know, users don't need to think about, you know, how to construct a whole solution from different smaller pieces. It has batteries included. It comes with mocks, snapshots, you name it, and it has pretty powerful matchers. So if you take a look at the code snippet here, it reads pretty similar to Mocha, like it has describe, it, block, blocks, and there's a synonym to it called test. Describe is optional. And assertion look like expect something to equal something else. So no chaining as in chai. So that's something. And what I wanted to mention is that in the second test here, we have expect my beverage to equal expect object containing. So this expect.object containing is called matcher. And it allows you to construct an assertion that matches whole ranges of values. And I think this is a pretty cool idea. Obviously, we're gonna steal it for Earl. But so why would you consider not to use jest? So first of all, it's kind of complicated. Like I'm pretty sure that most of jest users don't realize that jest will build AST of their test before execution, and it will transform them actually. So for example, it will try to extract some bits like import statements. It will try to hoist them so the mocking can work properly later on. So it's kind of complicated, and it does some things with your code that you shouldn't expect that it does. It makes debugging harder. So not only that I love that much doesn't really work because it's scoped to one test seed or test file actually. And console logs, sometimes they can be swallowed. I think if you turn on verbose flag, you suddenly stop seeing console logs. So that's kind of unexpected. It has unfortunately bugs in basic features, like you can use before each with asynchronous functions, and if the asynchronous function fails, like the rejection gets swallowed. And of course, there are like, you know, open issues that are open for many years on their issue tracker, and you know, there's not a huge progress in fixing them. And finally, it lacks type-safe assertion. So again, you can compare, you know, numbers with strings, and you will only realize in runtime that something's wrong. So let me introduce Earl. So Earl is a modern assertion library made for TypeScript, and it was born with the frustration with chai, and basically we were like looking at the whole ecosystem of libraries that are out there, and we were thinking like Mocha itself is pretty great, like it's pretty decent test runner, chai sucks. We don't like chai. But on the other hand, Jest is pretty good. It has many very nice features, but there are some other drawbacks that we can't really get around. So let's try to build a library that will take good parts of Jest and transfer these ideas to Mocha ecosystem and basically be a replacement for chai. So Earl features like powerful validators and matchers similar to Jest. It's type-safe, so it's designed to be as type-safe as possible. It's not only written in TypeScript, it's designed with type safety in mind. It has built-in support for mocks, so we're following this mindset of Jest to have batteries included. As I mentioned, it works great with Mocha. It features snapshot testing. Snapshots are, I think, a little bit controversial thing to use in tests, but I still think there are some good use cases to use them, and that's why we support them. And of course, you can extend it with plugins. And today, I don't want to, explain all the great features of Earl. I just want to focus on the features that might be interesting for people attending TypeScript meetup. So we're gonna focus on TypeScript related features. But first, let's talk a little bit about naming that we use in Earl. So here is a simple assertion, and we have expect not to equal something something. So to equal part is like a top level assertion, and we call it validator. And we have a bunch of other validators like to referentially equal, or to be a type, or to be a string matching something something. So so we have these validators which act as the root of your assertion, and I think Jest calls them asymmetric matchers. We just call them validators, and you can use matchers. Similar to Jest, you can use matchers with validators, and validators again allow you to match whole ranges of values. So for example here, and they're attached to expect objects. So for example here, we're expecting a number which is close to 1 plus minus 2. And we have also modifiers, and right now we have only one modifier called not, and it's used to negate the whole assertion. Okay, so let's take a look at how Earl provides type safety. So by type safety, I mean that the validators are aware of types, and depending on the validator, it will do slightly different things. But in the basic example, you want, when you're writing expectation, you're writing an assertion that you're asserting a number, then it should force you to provide a number as a expected value. So for example here, if you would provide 1 as a string, you will get a compile time error. And this not only brings this benefit of having a tighter feedback loop, like you write your code and you at the same moment you see if the test has even a slightest chance to run correctly. But it's also pretty great when you're conducting like a bigger refactoring in your code base. So imagine changing the output type of some function, and then you have basically all the mistakes in tests highlighted automatically for you. So that's pretty useful in my opinion. But it's getting a little bit more complicated when you're working with matchers. So as I mentioned, like matchers are some runtime objects that when validator like to equal sees them, it's executing a little bit different algorithm for comparing these two values. But we would like it to be still type safe, right? So we decided to hide the fact that actually like the the matchers in the runtime are anything other than the values that they will present, that they will match. So basically, like if you have a matcher called array with, which matches an array containing all of the provided items, basically it tricks type system to think that it's actually an array of strings in this example. So you might there are a couple of ways to implement something similar. We picked this way because it's the simplest one, right? Really, like you can imagine a way where matchers return some kind of matcher generic type, and then we have a map type that does this translation and checks if the types match. But this way was way simpler, and it works equally well, if not better, because it produces pretty nice error messages. So yeah, so we decided to lie in some function signatures. And the benefit of type safety allow us to quickly realize if users do something strange. So, for example, one of the limitations of JavaScript language is that you cannot have like an expression that is lazily evaluated. So, for example, if you want to check if a given function throws anything, you need to really pass a function, not like an expression representing this function. So usually you just wrap in a parameterless function another function or another call to check if it throws. And with Earl, we can just add generic constraint to ensure that whatever is used with to throw is a parameterless function. So if you decide to call it, we're gonna get a compile time. So we can also, help our users with some common pitfalls by using type system. Now let's talk a little bit about mocks. So currently Earl features only function mocks, and mocks are basically dummy functions that can be executed by a piece of code that we want to test, and later you can easily assert that there were some parameters passed, or you can instruct easy mock to return some values. And seen on SPY, just mock fn or mock fn are all pretty similar concept, but of course our mocks are fully type safe, and we also put a little bit more thought into making a fully synthetic mocks quite easy to work with. So here we created a mock, which is a function which takes two numbers and returns a number. So we could call it like this, and it's a valid call, but at this stage the mock is not configured to return anything, so it will throw an error. To make it work, we need to configure it in some way. So the simplest one is to use return once, and we can say that, for example, when called, it will return once for, or we can actually say that we always want to return for. And what's pretty cool is that we can add more constraints to this mock. So we can say that that given some arguments, like for example 2 and 2, we want to return once 4. And what's cool about it is that, again, we can use obviously matchers here. So we can do, I don't know, number close to 2 with delta of 2. So I don't know, we can use it in such to construct the synthetic mocks quite easy. Furthermore, when you're done with your test and you want to assert that there were some interactions with the mock, you just use to have been called exactly with, and you pass an array of arrays of arguments. So that part is quite standard. What's also interesting is that you can use it as a regular, like exactly as you would use Sinon.spy. So you can just pass a function, and all the type arguments would be inferred from this function, and it will be always used to get like the default response from the mock. But in this case, it's an asynchronous function, so we can again use some helpers that we provide like for asynchronous programming. So here we can make the mock reject once with some kind of error. And of course, it's type safe. You can only do this if the output of the mock is a promise of number. Then let's talk a little bit about TypeScript's assertion functions. So you might be familiar with this feature. It's quite a recent addition to TypeScript, but if I'm thinking now, it's probably 1 year old already. So if you remember type guards are functions that return Boolean value in the runtime, but on the type level, they can change flow. They can change the type of some variables by using other flow instructions. So, for example, you can do if is string value, and in that block the value will be actually a string if the type guard is programmed correctly. And assertion functions are pretty similar in this case, that they can change a type of some variables in the outer scope. But here they work in a way that either their return either they throw. So you don't need to use if statements or anything like this. They will just throw if the condition is not met. And let's see how it works in practice. So we have this input of type unknown, and we assert that it's an instance of string. And after this assertion, compiler actually knows that either it's a string or the assert functions would throw, and essentially like this code would never be executed. So a compiler can assume that here it's actually really a string. And if you would try to move this above, we get a compile time error. So you might be wondering, does Earl support this feature? And unfortunately, it doesn't, because right now assertion functions are pretty limited. They work only with functions. Like you cannot have methods or anything fancier than pure functions. And that's why it doesn't work with Earl right now. It's one of the things that makes me sad every night. But in fact, like assertion functions could be abused to come up with many other interesting things. Like you can imagine a class that represents a connection that can be closed or open. And with assertion functions, if they would work on the function on the class level, you could come up with a type that couldn't be closed twice, because after closing it once, it would become a different type that could be only opened. And that's something pretty cool, but unfortunately it doesn't work with TypeScript right now, but who knows, maybe it will be improved in the future. Another thing that I wanted to mention is that Earl support extensions, and extensions can be used to load new validators and matchers or some other features during runtime, and probably they're not that interesting. But what's interesting about them is that since like whole Earl ecosystem is written in TypeScript, we come up with a pretty nice way to automatically derive TypeScript types for these plugins. So let me present this. So the problem that we're often dealing with while developing any sorts of plugins is that plugins change the types of the original library that they're come in interaction with. So for example, here we have a plugin that loads a validator called to be even, and you would use it like, you know, expect something to be even. And this to be even is not part of, you know, Earl score, so it needs to be loaded. The type about this method needs to be loaded by the compiler, you know, on the fly. And for this, in TypeScript, you use this basically module augmentation and interface merging. And this might be a simpler concept, but in practice, there can be a pretty hard to implement properly. Like you just leave one statement that shouldn't be there and suddenly it doesn't work, and the errors are totally hard to understand. And this is something that actually Karol, one of the organizers of this meetup, helped me on Twitter and pushed me in the right direction. And at the end, we ended up in the way that if your plugin is written in TypeScript, you can derive all of the important types from your plugin definition using, you know, typeof, and then from this you can create this interface to be merged into our score totally automatically. So that's pretty cool. I think that for, you know, TypeScript programmers, there's actually zero hassle to provide high quality typings, even when they change third-party libraries. And we're getting to the end of my talk, really. I want to mention quickly future plans for the library. So obviously we keep on adding more matchers and validators. There's also a plugin in development for smart contract development. So it will actually replace some set of chai matchers. Inline snapshots, it's something pretty cool that I would like personally to see supported in Earl. Like currently we support only normal snapshots that end up being dumped in the file. I didn't demo it because it's not very interesting for TypeScript folks, like it works. And other area of focus is that we're thinking about developing some test utils. For example, you know, things that are not necessarily related to assertion library, but I don't know, things like knock related helpers or fixture helpers or some asynchronous programming helpers or things that can help you with module caches. Like things that you would, some of these things you can find in Jest, and that's why we also wanted to make it part of Earl to, you know, follow this batteries included pattern. And that's really it. If Earl.js sounds interesting for you and there's a chance that you want to use it in your next project, just head to our GitHub or direct it to the docs page. There's a QR code for you to scan. And if you enjoyed this talk, consider following me on Twitter. I'm Kaczor on Twitter, and I tweet a lot about TypeScript, software automation, and a little bit about cryptocurrencies. Thank you.